Hello, it is Math with Beth, and we are going to look at absolute value graphs and also how to graph them with transformations. So we're going to start with the parent graph, which means the simplest version of an absolute graph. So it's just the absolute value of x. If you don't already know what this looks like, remember you can always recreate it by picking any values of x you want, plugging them in to see what y value would go with them. So I'm just going to do nice and simple. -2, -1, 0, 1, and 2. If I plug -2 in to this, I would need to take the absolute value, so it would become 2. If I plug -1 in there, same thing, y would be 1. If I plug in 0, y would be 0, because the absolute value of 0 is 0. If I put in 1, and if I put in 2, I get 2. So if you graph this, you would see that it makes a V shape, and it keeps going forever. We just didn't put in every number possible. So make sure you expand your lines and add arrows. So this is your standard absolute value graph. If you needed to know the domain, remember you go from left to right. So since we hit an arrow on the left and an arrow on the right, it means all of the numbers are being used. So that's how you write that. And for the range, you start at 0, and then every number on top of 0 is used. So the range is from 0 to infinity. So now what happens if we have some transformations? So this actually moves us to the right, because it always moves us left or right, and it's the opposite of what you would guess. So this graph is going to move to the right 1 and up 2. So I could easily do that. But I just want to show you, if you use the parent graph, which again, you could recreate really quickly if you didn't have it memorized, you could use that to then transform the graph however you want, because these are going to get trickier. Look at the one down here, is going to have a lot more happening. So I'm going to show you how to do it with this easier one. Because of that -1, remember we always think of it as the opposite. So I'm going to add 1 to all of my x's from my parent graph. And because of that +2 outside, I'm going to add 2 to all of my y values. So instead of having to physically move the graph around, I'm just going to do that, add 1 and add 2 to the points I already had. So -1 would become, -2 would become -1. -1 would become 0, 1, 2, and 3. Now I'm going to add 2 to all of these because of this. So that would become 4, 3, 2, 3, 4. So -1, 4, 0, 3, 1, 2, 2, 3, and 3, 4. So again, I could have done this by just taking my original graph that I had up here, the parent function, moving it 1 to the right and 2 up. I could have done that pretty easily. But this method is good to know for when the problems get trickier and trickier. So down here, this one would be a little tricky. I'd have to move to the left, down. I'd have to flip it because of the negative, and I'd also have to change the shape and make it skinnier because of the 2. So instead of making sure I do all of those things, I'm just going to do it with the numbers. So again, have your parent graph numbers handy. And then make sure you do the correct transformations. So the only thing that affects the x is stuff that happens in here. So that is only that +3. And we do the opposite. Everything else affects the y. So that -2 is going to get multiplied by the y. And then I'm going to have that -1 at the end. So -2 minus 3. -1 minus 3. 0 minus 3. 1 minus 3, and 2 minus 3. That one's pretty easy. This one, just be careful. Make sure you multiply first and then subtract 1. So 2 times -2 is -4 minus 1. 1 times -2 minus 1. 0 times -2 minus 1. 1 times -2 and 2 times -2. The more you do this, you'll start seeing that there's always going to be this pattern. So if I had -5, -3, 1, and then I had -3 and -6, that should catch my attention that something's off there, because these are always going to be symmetrical V shapes. So you should always have some kind of pattern like this. So -5, -5, -4, -3, -3, -1, 2, -3, 1, -5. Okay, let's try another one. So this one has a lot going on also, but it makes it a little trickier because there's a number being multiplied by the x inside the absolute value. So first of all, that's going to affect the x, but second of all, we would prefer it written like this, where that 2 is pulled out of here so we could really see what number is being added or subtracted. So if I pull that 2 out, that really would become x minus 3 inside. So now it's the -3 that I'm going to have to deal with when I do the transformation, and then the +1. So parent graph again, just because it helps me to see it right in front of me. And now what do I need to do? I need to multiply my x by 1/2, because we have to do the opposite. So instead of 2, I multiply it by 1/2. And then instead of the -3, I'm going to add 3. So the stuff inside the function is always tricky because opposite, opposite. For the y, I'm just going to add that 1. So the x is going to be tricky. -2 times 1/2 is -1 plus 3. -1 times 1/2 is -1/2 plus 3. So that's going to be 2.5. 0 plus 3. 1 times 1/2 plus 3 is going to be 3.5. And 2 times 1/2 is going to be 1 plus 3. So again, you see there's a pattern. Instead of going up by 1 like we've been doing, it went up by 1/2 each time. So again, you could hopefully catch a little mistake if you made one. And then for the y values, I'm just adding 1. And again, you see that pattern, 3, 2, 0, 2, 3. So it's reflexive. Okay. New points, 2, 3, 2.5. Wait, oh, I already made a mistake. I'm going to graph it down here. Sorry. 2, 3, 2.5, 2, 3, 0, 3.5, 2, and 4, 3. So it's skinnier than the ones we've been doing because of the 2. So this would be our graph. So basically what I wanted to show you is that if there's stuff happening inside, be extra careful. And if it's a number with the x, start by factoring that number out so you can see exactly what number you need to multiply by when you flip it, and what number is really being added or subtracted, so you can do the opposite of that as well. All right, I hope that helped. I will see you next time.